Okay. Hi there. So today we will continue with the previous slides, and we were discussing about data mining functionalities. Part one is in the previous um, video, and in this one we are going to continue with the same topic. So the next functionality of data mining is cluster analysis. Now, unlike your classification and prediction, which we have discussed earlier, which analyzes your class label data objects, clustering basically analyzes data objects without knowing your final label of the class. So that's why it is written over here, your class label is unknown in clustering. So what we have to do, we will try to understand this clustering through an example. You have to group data to form these new classes, like cluster houses to find distribution patterns. Okay, maximizes your intra-class similarity and minimizes your inter-class similarity. Basically, we will group the data on the basis of their similarity. Okay, intra-similarity means within a group, they all the things that are present in one cluster, they are similar to each other in some form. Okay, and interclass similarity will be minimized means the attributes or the values that are present in different clusters, they have less similarity. They are not similar. So you can take an example. Suppose I'm having three. Just general example I'm taking right now for just to make you understand what are clusters, what are groups. Okay, so there is a room, and in that room, randomly some papers are distributed, and those papers are of color red, blue, and green. Okay, and they are randomly distributed. What I want to do, I want to group up the red color papers as one cluster, blue color papers as second cluster, and green color papers as third cluster. So what I have to do, I have to check. If I will talk about these digital images, I will check the intensity of them. Okay. Now in that room, what I have to do, so right now, just to make you understand, I'm trying to make the clusters of three different colors. Yeah, and how will I do that? I will check whether I will make three centers. One center is with red color, another center is with blue color, and third center is with green color. Now I will check one by one the papers that are distributed randomly in a room. I will check which, suppose first I have taken out that green color paper. So I will check it with the first center that is of red color. So it is not matching with that one. So I will not group it with it. Then with second one that is blue color, it is not matching. So we can't group. Then third one, green color, yes, it is matching with this one. So we will group that paper with the third center that is of green color. In the same way, we will see all the papers that are distributed randomly, and we will group them up. So we will have this segregated information or the clusters. The cluster one will have only red color papers, cluster two will have only blue color papers, cluster three will have only green color papers. So that is basically, you can say, in a general form is called as clustering. So clustering can be utilized to generate such kind of labels. Okay, they are grouped, they help to group up the values, or you can say the attributes in the data on the basis of their similarity parameter. Yeah, and one another example that you can take is of your electronic shop data. Okay, is available to you, some customers location are there. Okay, so what you have to do is you want to cluster up the customer locations. You want to check from which area you have more number of customers. So what I have done, I have taken three particular areas, and I made the center in that areas. Now I started checking one by one with the customer location data whether this particular location is near to this center, or this center. So now it is near to this one, so it is grouped up with this one. So similar kind of example. Okay, so in this way we have performed this clustering, that is called as clustering. I hope you understood the point. What is the meaning of clustering analysis? Yeah. So here each cluster which will be formed, it can be viewed as one class of objects from which rules can be derived. Okay, so here the observations into a hierarchy of class that group similar events attributes together. Yeah, so that is your clustering analysis. Now let us move further. Next functionality of data mining is outlier analysis. Now, what are outliers? Basically, if we are considering the same example, let me make you understand with the same example that we have taken of red color, blue color, and green color in a room. Now we have already grouped up. The red color papers are in one group, blue color papers are in another group, green colors are in another group. Yeah, that example I have given to you for make you understand clustering. Now let us assume there are some papers left. Yeah. Now what are those papers? Suppose I have taken up one paper. That paper is neither green nor blue nor green. Okay, neither blue nor green nor red, any of the three. Now what I have to do with that paper? So that will not be a part of any of the cluster, that remain outside. There are some more which are not matching with any of those clusters that are mid centers. Yeah? So they remain outside. So they become our outliers. They are the outliers. Okay. To analyze outliers, it will help us to remove the noise. If we will get the outliers in data, that means it will help us to know how much noise is present in your data set so that we can tackle it. Now you can understand the definition of outlier: data object that does not comply with the general behavior of the data. Now, general behavior of our data was we were just checking red color papers, blue color papers, and green color papers. Now, those objects which are not matching up with that general behavior of the data that we are studying, they become the outliers. Okay. In noise or exception, this outlier analysis comes. It is useful in fraud detection, which are the ones which are not behaving in the same way that we want them to behave in our data set. So it will help out in finding out the frauds, rare event analysis. Okay, so that is called as your outlier analysis. I hope you got the point. Next one is your trend and evolution analysis. Now evolution term we have already seen in starting also, where we have studied about our database evolution or data warehouse data mining evolution from database technology. Now data evolution analysis, it basically describes the regularities or trends for the object. Basically what we are trying to do over here, we want to study the data on the basis of the time. Some study according to the time, changes over a period of time, you can say. Okay, so this kind of analysis can include your characterization, discrimination, classification, clustering of time related data. One example you can take of your stock data analysis. Okay, so this example you can understand it in the way, suppose you want to invest in particular stock. Yeah, and you want to understand the behavior of that particular stock in previous 10 years. Now you want to analyze how, whether you should invest in that stock or not. And for that one, you have this previous data available to you, and what changes have came over a period of time in those 10 years that you are studying for that particular stock. Okay, so that kind of analysis is called as your evolution analysis. Here example is given of regression analysis. Obviously that can also come up for regression analysis. Suppose I'm studying the um, I want to analyze or I want to predict the salary of the employee on the basis of the experience. That can be an example of regression. Basically, over a period of time, what should be the salary of an employee? If an employee is having 1 year experience, what should be the salary? 2 years experience, what should be the salary? So that is changes over a period of time we are studying. Periodicity analysis, again about particular period we are talking. Similarity based analysis, that can also be done using evolution analysis. So in a period of time or a particular trend we are studying, so that kind of analysis happens during this evolution analysis. So all these functionalities, this is the fifth functionality that we have just covered up. Okay, and this is your That was your last functionality. Yes, that's it about your data mining functionalities. Let us move further. Till now, if you are having any doubts, please comment and discuss with me. Next topic. Now, the next topic is about primitives. Primitives that define a data mining task. Again, a very important topic from your exam point of view. Okay. We will see one by one what are the primitives of data mining, and here in your syllabus the topic is like your data mining task primitives. In this way we are going to cover up one by one all primitives of data. So basically here we can say that like data mining system, like to communicate with data mining systems, users can utilize these data mining primitives. Okay, that is the meaning over here. Now there are different data mining primitives available that we have to utilize. First one is task relevant data. One by one we will cover up. Task relevant data basically is a kind of database portion to be investigated. For example, suppose you are taking an example of your electronic shop again, and you have this shop available in any two countries, suppose in India and USA. In particular, you would like to study the buying trend of customers in India. So rather than mining on the entire database, you can just specify about the customers who are purchasing in India. That kind of information is need to be retrieved. Okay, along with the customer profile information, you can say. So they are referred to as relevant attributes, which we are asking along with that one. Okay, so task relevant data, basically that is called as a task relevant data. What is the data set that I want to mine? Okay, so that I am interested in and that I want to be like to be retrieved. Okay, so that is task relevant data. I hope you got the point. Now it can be these kind of queries can be on your uh, what do we say, data warehouses. Also we can run on data warehouses. In data warehouse you say data typically stored in your multi-dimensional data, and that is nothing but your data cubes. Uh, so we can extract the information by performing different operations like filtering, slicing, dicing, okay, on the data cube. That kind of task relevant data can be extracted from data warehouses by utilizing these operations. Now, condition for data selection, relevant attributes or dimensions, data grouping criteria. So these are certain like functions, or you can say like different functionalities that you can utilize to extract the information related to the data which for which you want to work. Okay. Now, the set of relevant attributes basically they may involve other attributes which are not mentioned separately, but which should be included because they are implied by the dimension involved in the set. Okay, so for example, you can take this example of that may be part of some hierarchy. Okay, like street, city, street is present in some city and city is present in some state, included in the set of relevant attributes since they represent some levels of abstractions of setting. So this facilitates the mining of knowledge at multiple levels of abstraction. And you can perform different operations on them like drilling operation, drill up, drill down, roll up, roll down. Those are the operations that we can utilize to extract the information. So that is task relevant data. Grouping criteria, on what basis you will group them up, on the basis of the similarity and dissimilar data you will segregate out. These are the operations that you can perform utilizing queries on simple DBMS or utilizing some operations on data cubes or performing or some analysis for retrieving the relevant information for your analysis. Next one is the kind of knowledge to be mined, type of knowledge to be mined. So this topic we have already done. Okay, type of knowledge to be mined on there we have discussed about characterization, like to summarize the data, discrimination to compare the data, association rules we have discussed, classification, prediction we have discussed, and clustering. Just now we have covered up this thing on in functionalities, clustering, outlier analysis, and other mining tasks like your evolution analysis. So this topic has already been done, and we are not going to see it again. If you have not seen the previous videos, please go to the previous second and third video. You will get the complete idea about these topics of characterization, discrimination, association, classification, clustering, outlier analysis, and evolution analysis. So that is about our type of knowledge to be made. Now third one is background knowledge. Fourth one is pattern interestingness measurement, and last one is visualization or presentation of our discovered pattern. So one by one we will see them. Third is background knowledge. Background knowledge, when we are talking about background knowledge, basically we have to see about concept hierarchies. Now, what are concept hierarchies? Concept hierarchy defines some sequence of mappings from low level to high level. Generally, we say like that. So, for the dimension of location, we can say it like it can be represented in the form of a particular country, under which what states are there in that country, and under which what cities are there in that state, and in that way. So from low level to high level we are representing some knowledge. So that is your concept hierarchy. So hierarchy, the term itself is telling us we are talking about some levels, and you can relate it with the trees from your data structure subject. Okay. Now the concept hierarchy as particular node is organized in a tree. Each node will represent some concept. Okay. There will be these levels available to us, and we can perform different operations on that particular concept hierarchy, like drilling down, drilling up, rolling down. Those operations can be performed on that one. So you can imagine it like as it is being shown over here: street, city, province, or state, or country. This is going from low level of street, that means your particular address, to the higher level of country, particular country. So it's like if I want to represent some information about locations where it is representing all the countries, and under which the next level will become the countries like your USA, India, Canada, in that way. Then next level will become the cities of it. Under USA it will come like New York, California. Under India it will come like different states of Telangana, Delhi, Haryana, in that way. And under which different sub level will become like your street, your particular address, particular area, you can say it like that. Okay, so that is your concept hierarchy. Now concept hierarchy has some categorization. One by one we have to see what is the meaning of those categorization. First one is schema hierarchy. Schema hierarchy is basically you can say it like a total attributes in the database schema. So schema, what is basically schema? Schema is nothing but the structure of your data set. So it gives you complete information about the attributes of your data, how much record is available under that attribute. That information will come in schema. So schema hierarchy will give us the metadata information. Now what is metadata? Metadata is nothing but our data about data, a particular data, and about the data some information is available to us. So that will give us the information like data about data. So this example that is written over here is nothing but the example of your schema. So street, city, province or state, and country. So this means that street is at lower level than city, which is lower than your state, which is conceptually lower than your country. So the schema hierarchy provides this metadata information that is about your data about data, and it gives this total or partial order among the attributes in a more precise way. That is your schema hierarchy. Next comes up your set grouping hierarchy. Set grouping hierarchy, basically we have to make some set. If we want to perform some analysis on particular group of the data, then we can first separate them out in sets. Like here in this example, suppose you have some data available of your customers, and from those customers I want to perform some analysis in the age wise criteria. So I have divided the age groups in the range of 20 to 39 is young age, 40 to 59 is middle age, 60 to 90 is senior aged people. And I have made them like a group to show it like a young, middle aged and senior. All are grouped according to age criteria. Now I want to perform some analysis on this one. Suppose I want to check the how COVID has affected this age group of people. Okay, so that kind of analysis I can perform. This kind of scenario is called as set grouping hierarchy. Okay, next one is operation derived hierarchy. So operation derived hierarchy is basically it is based on operations specified by users or experts or your data mining system. Now here you can see through the email address, we can extract some information. Suppose you are having some email address data available with you, or some domain related data available with you from Google World Wide Web. So from that email address or from that domain, what you can extract, what kind of information you can extract. Through this email address, you can extract like information about from which country is it, which university is it, which department is it, what is the login name. So that is making one concept hierarchy over here from lower level to higher level that we can represent. So suppose you are having this a large amount of data set available with you of email addresses. From those email addresses, you want to analyze about particular country, then you can extract the information from those email addresses. And on those concept hierarchies, you can perform your different operations to extract the information. Last one is your rule-based hierarchy. Rule-based hierarchy, if you remember, we have talked about your association rules. So in the same way, suppose in your, I'm taking this example of your electronic shop data, and I want to see what is low profit margin. Like I want to check how much profit has been made in that shop. So I'm making this rule to check that profit. So for the profit criteria, I made this rule of price, actual cost, and your retail cost. Okay, the difference between your these two will give us the profit margin. So here it has been shown it like a low profit means if the difference is less than 50, it will be like low profit. In the same way, I can make another rule like medium profit. Medium profit can be like if the difference is between 50 to 200. That will be defining the rule for your medium profit. If I'm making it like for high profit, I can make it like if the difference of two prices, actual and retail prices, greater than 200, that means the shop had high profit. So these are the rules. In that way, we can show that is called as rule-based hierarchy. And level wise, we can show it like for low profit, medium profit, high profit, how much we have done. So that is called as rule-based hierarchy. And that is the concept of your concept hierarchies. Okay, very important concept from your exam point of view. Definitely question can come up separately about concept hierarchies. So you should know about its categorization, all four, what is the meaning, and with an example you should know to explain it. Next primitive is pattern interestingness measure. So interestingness measure means how much interesting that particular pattern is that is being evaluated. There are four criteria for that one. First one is your simplicity. The pattern should be simple. It can be, you can relate it with your association rule length. Like for in previous example we have seen for extraction of information related to profit. Okay, so if the rule will be very lengthy, it will become difficult to work that one. Okay, so it will become difficult for the people to understand also, and it will increase the complexity. If the pattern is interesting, that means it should be simple and it should be user friendly. It should be understandable by the user. That is the meaning. In the same way, if the tree size for making decision tree sizes we are talking about here, If the tree size is very huge, that will increase the complexity and that will increase the difficulty for the user to understand. So that should be again user friendly. Next parameter is of certainty. Certainty basically is measured in the form of confidence. Confidence we have already seen previously with association rule. If you do not remember that one, please go to the previous video and check it out. Now, let me recall you. Confidence basically is a measure of probability. We want to check how many chances are there for the particular event to occur that we want to see. So here you can see it like a probability of A and B, probability of A and B divided by probability of B. So we want to check how much certainty factor, rule quality or a rule strength it is giving to us. Like I would like to make this rule in association, like the people who are buying laptop, how many chances are there that they will buy pen drive also along with laptop? So I will say if the confidence is 60%, I can say it like 60% is a probability that the customers who are buying laptop, they will also buy pen drive. That is called as certainty. Okay. Next parameter is utility. Utility is basically measured in terms of support. Support is nothing but the true event that already happened. So if I'm taking again the same example, the customers who have bought laptop, they have bought pen drive also together with it. So if I'm saying like support is 5%, so I will say for the study of electronic shop, that 5% of the customers from the total customers that I'm studying, 5% of those customers who have bought laptop, they also bought pen drive along with it. So that means that that event has already happened and that is true. So support is basically representing us the truth value, and certainty, that means confidence, is representing us the chances of that event to happen in the terms of probability. Okay, what is the probability of that event to happen? So these are the two factors. Next, second and third one. So first one was simplicity, second one is certainty, third one is utility, and last one is novelty. Your pattern that you have discovered, it should be novel. It should not be previously known. Okay, it should be surprising with some improved performance or with some improved accuracy. There should be removal of redundant rules. So basically it should be new. Okay, it should not be previously known. That is your next primitive of pattern interestingness measure. Last primitive is your presentation. So obviously when we are talking about presentation, we have to represent our discovered knowledge or our results through some tool or through some we need some platform to represent our results. So what can be that one? So here you can see over different backgrounds or usages may require for different forms of representation. Like you can represent your results in the form of tables. You can represent your results in the form of bar charts, pie charts, rules. Okay. So these are different ways to represent your final discovered pattern or discovered knowledge. Concept hierarchy here also becomes very important. Discovered knowledge might be more understandable when they are represented with levels of high levels of abstraction. So if we are representing our discovered knowledge in the form of levels, it can be more useful. So interactive operations on that concept hierarchy can be performed. Okay, so it will become more of the user friendly. So we can perform different operations of slicing, pivoting, dicing. So obviously these operations are going to be, we are going to discuss them in very much detail in your unit number 2. But right now, what is important for you to understand, yes, if we will have this extracted information in the form of concept hierarchies, it will become easy for the user to perform these operations and they can extract information as per their requirement. Okay. Now, these different kinds of knowledge can be represented by utilizing association, classification, clustering. So this point we have already seen many times in previous slides also. Here, what you have to remember for our representation of discovered patterns, what are different platforms available to us. Okay, so that is your task primitives of data mining. So that's it. We have covered up about functionalities. We have completed about functionalities of data mining. Then we have seen primitives of data mining, task primitives of data mining. So that's it for this session. And in next class, we are going to cover up about integration of data mining with data warehousing. So we are going to see these coupling techniques to couple up data mining, data warehouse, and mainly you can see it like with database also. So thank you so much. That's it for this session. Keep showering your love to the channel. Please subscribe, share, like, and comment. If you are having any doubts, please discuss in the comments. Thank you so much.